Welcome back. Sometimes it is difficult to visualize spatial patterns. For example, dot maps may have overlapped points, and lines may not be explicit enough to provide geographic context to our maps. Today, we're going to learn how to build density maps and base maps. Let's start. So, as in previous occasions, you can pause this video and read through the learning objectives. So let's start with density maps. So a density map is a thematic map where colors represent the intensity of a value. It does not use geographic regions or geopolitical boundaries to group data. It shows hotspots or areas with a high density or concentration of points. So in this figure we see the Jon Snow dot distribution map with dots and lines as background. And in the right we see an alternative plot, a plot that contains a density map in which we can highlight the hotspot with a higher amount of cholera deaths. So how can we plot it? So for this we're going to use as an example Afri Airports database from the Afri Learn Data package. It contains the location of all the African airports. With the geomsf function, as we remember, we can get overlapping points. So if we run this piece of code, we can see that we indeed obtain a dot distribution map, but it contains a lot of overlap points. These overlap points difficult the possibility to identify some spatial patterns. For a density map, we require 4 main steps. First, we need to retrieve the point coordinates from our data frame. Then, we need to specify a ggplot with new coordinate columns for the x and y axis. Third, we need to use the geom_bin to the function to depict the number of airports per area. And 4, we can use the coord_sf function to transform the axis aspect ratio into a coordinate format. So let's work this example. So the Afri Airports dataset contains a lot of IDs related with all the airports and different values related with it. First, we need to retrieve the coordinates that are located within the geometry column. And for this, we need to use the st coordinate function from the epi-helper package. With this step, we now have in separate columns the x and y coordinates. Now, as a second step, we need to start our ggplot2 object. As a second step, now we need to build our ggplot2 function. And for this, we need to specify the coordinates in the aesthetic function. As a third point, we need to use the new geom function, and this is called geom_bin to the function. Now we have our density map, but we need to fix the coordinate axis, and this is where the coord_sf function comes into a scene. So now we have our map, our density map, with the right x and y coordinates. With this presentation, now we can see hotspots of higher amount or count of airports per area. And now let's practice. Your task is to create a density map with a pre-crime data from the pcrime.rds local file. With this, you're going to use the geom_bin2d function to portray the number of our crimes per area, faceted by two types of crimes available in the column marks. So let's start. Now, how can you use density maps? Density maps are commonly used with environmental data. For example, you can visualize altitude, air pollution data, or rainfall data. In this example, you can visualize the altitude data from the Gambia. This type of map is also used for spatially continuous disease prevalence surfaces. For example, Moraga and colleagues used this type of figures to visualize the malaria prevalence across the Gambia from data collected from 65 villages. This is the surface of prevalence of malaria, and we can visualize the main hotspots of malaria prevalence and also the locations that have the lowest ones. The authors used a geostatistical model to predict the disease prevalence at unobserved locations. Now, we can make alternative density maps than the one that we built before. For this, we need to add certain variations into our code. For example, with ggplot, we can make two alternative plots. We can use, instead of the geom_bin2d function, the geom_density2d field function. And in this case, we are going to have a contour density plot of count values. For example, we can maintain the steps number 1 and 2, and as an alternative geometric function, we're going to use the geom_density2d field function. And we're going to specify as a contour variable count. Let's read this code and see the output. Now we can visualize again two main hotspots of the higher amount of airports within the Africa continent, and other type of patterns. So this visualization could also be a good alternative to visualize density plots. We also can use the stat_density2d function to create continuous surfaces of count values. For example, we can maintain our two first steps to build this map and then use the stat_density2d function with all of this content. Because of the amount of code, we're not going to get into writing all the content, but we can use the geometry called raster, and as a mapping, specify that we would like to visualize the count data as a field for the field argument, and remove the contours of this map. Let's find out the answer. Okay, so this is a really nice alternative density map that that allow us to have like a continuous surface of the values. In contrast to the first plot, we have areas depicted by squares, and in our second alternative, we have contour regions. With this alternative, we have a continuous surface of values. So now it's time to practice. Let's use the st_coordinates_tidy function to extract the x and y coordinates from the pcrime dataset. These coordinates will be useful to build a density map with a geom density to the field function and portray the number of crimes per area. So let's go ahead. Okay, so now let's talk about base maps. So base maps are an alternative to the physical feature maps. As we remember, we can use lines for physical features and get a partial geographic context. But we can also overlay the map over a Google Maps-like background. For example, in a dot map, we're going to recreate our London cholera outbreak dot map. As a reference, you can see this Jon Snow dot map with the size of the points proportional to the number of cholera deaths. We can overlay this plot to the London street map. So let's use the GG spatial package to do this. For this, we're going to use the annotation map tile function to add one more layer to our map. This function uses data from the OpenStreetMap project. So let's see how to reproduce this example. So as reference, we can see the content inside the cholera deaths, and we have ID, the count of deaths per location, and the geometry column that contains the positions. So here we have our classic beginning of a ggplot2 function, and at the end we have the geomsf function that allows us to create the dot map with points proportional to the count of cases per location. To add a base map, we only need to add the annotation map tile function. So let's run this piece of code and get the output. This code can take a couple of seconds to get the result. Now we have our dot map with each dot proportional to the count of deaths per location above a base map that contains the name of the streets and more detail about the buildings around the area of cases. Now let's practice. Please add a base map to a dot map using the AfriCapitals object and also the annotation map tile function. Let's go ahead. Well, how to add a base map to a density map? For this, we're going to use as an example the pcrime object and the annotation map function. Okay, so let's build above our scaffold of how to build a density map. First, we extract the coordinates, then we start our ggplot2 object, and between the steps 2 and 3, below the geom bin to the function, we can add the annotation map tile. Remember, base maps need to be below the geometry that we want to plot. So let's run this piece of code to see the output of this example. Okay, so now we have our output, and we can visualize two types of crime in London using a density map over a base map with more explicit background than only lines for rivers and streets. So let's remember that our base map must be below the geom function. So now let's practice. Let's use two functions, annotation map tile and geom bin 2D, to add a base map to a density map using the Afri Airports object. Please, go ahead. Okay, so now let's wrap up. In this lesson, we have learned that density maps allowed us to avoid overlapped points in spatial data. And we also learned how to add base maps for Google Map-like backgrounds. Now you are able to reproduce these two types of maps with your data. But now, how can we use data from external GIS softwares? Let's find that out in our following lessons. So hopefully now you're more comfortable with creating density maps and adding really explicit base maps as backgrounds for your spatial data. So see you in the following lesson.
For more resources, visit our website, where you can track your progress, access interactive quizzes and lesson notes, and connect with our teachers and other learners like you. And if you'd like a more guided experience, we also offer live online bootcamps with expert help. So join us at thegraphcourses.org to start your learning journey today.